Ignite, students. It's a good day. Today, Sedimentary Rocks. What we're going to do is you know what? They're the 2020 mascot rock. Of all the rocks, Sedimentary are the 2020 mascot rocks. You take something that was already a rock, was strong, it was stubborn, it was in place, and it was doing its thing, and then you break it down. And then you transport it, you move it somewhere else, you drop it off, you compress it, you compact it, you cement it, and it's stuck in place there. That's the 2020 motto rock, all right, mascot rock. What we've got is you have weathering, erosion, deposition, then you have compaction and cementation going on. We're going to start. All of this is pretty cool. You can see a lot of this. This is Canyonlands National Park out in Utah, okay? There's a whole lot going on. You can see lots of things at this exact park and in different images that happen there. We're going to start with weathering. Weathering comes in two types, chemical and physical. Physical is probably what you're thinking of. Physical is probably what you're thinking of. Hey, look, wind weathers these rocks. Wow. I mean, you get some weird shapes. Wind and doesn't have to be wind. What could it be? Water, wind, gravity, and ice. Those are the agents. Those do the erosion. Here, you have weathering of the rock here by the ocean. It is breaking the rock down. Weathering is breaking down. Weathering is the breaking down, just making it smaller, breaking it into bits. All right? All sorts of weathering going on. Ice. You get a little crack in there, water gets in there, it rains, it freezes, water expands, wham. Water will absolutely fracture rock just like this. No problem. Water can do that. Water is crazy. All right? Some of the weathering going on here, well, you have all along this shoreline, you have rocks that are being broken down into smaller rocks. Now, after weathering, there's erosion. These two kind of bleed, they bleed into each other, they overlap a little bit. What's the difference between weathering and erosion? Well, let's use a little picture. Weathering breaks the rocks down. Erosion moves the rocks. One makes a big rock small, the other moves the small rocks. It can be the same thing. Water can run up on this shore and the waves and the tide can break this rock down and can also move the rock. So the same agent, the agents are water, wind, gravity, ice. I mean, those are the things that do the eroding. Those are the things that move the rock. So think sandstorm. You've got sand in the wind already. If that sand is pounding the other rock, it's not only weathering it by breaking down the big rock, but it's also then the wind is transporting that sand further and eroding it away. All right. Here's a picture trying to show the same idea. If you just use the waves to erode the rock surface, you would have this. But if you just use the waves to weather the rock surface, see, this is like backwards. These people don't see. I forgot to proofread my pictures. This is backwards because weathering breaks this rock into small rocks. Eroding then uses the tide to pull those little rocks out to sea. And you would have a cleaner beach. Okay. Now, erosion can also be like this. That's more of a sinkhole. This is water eroding and moving rock away. Soil erosion is right here. Soil erosion and rock erosion, I know we're talking about rocks, but erosion is erosion. You are moving material away. This is something that if you see along the edge of a field, there's big problems. You're not going to grow good crop in that field. Your cattle are going to break their leg. All sorts of things you're worried about. It's going to go right under the fence and create this cavern, like all of this dirt erosion. We don't need that one next. Okay. Deposition. Deposition is to deposit, to drop something. Okay. Deposition happens when the thing that does the eroding loses energy. If you have a fast-moving river, and that river is picking up and grabbing all the rocks and grabbing all the breaking off the little bitty rocks on the side, and they're carrying it downstream. Later, when that river flattens out and slows down, the rocks will then settle to the bottom, and they will be deposited. Big rocks will fall out first. Medium rocks will fall out further downstream. Small rocks and sand will fall out even further downstream. Happens in a large area. That's all deposition. It's depositing. You're dropping stuff off. So this is Cape Cod, Massachusetts. I'm not really familiar with the area. Maybe I'll go there someday. Maybe not. I don't know. We like to travel. See, if we were in person, I'd ask you right now about your traveling and who's been here. But any shoreline, any beach, it's interesting because tide comes in, tide comes out, sand comes in, sand goes out. But there are areas where sand is being eroded and moving away, and there are areas where sand is being dropped back off and deposited. So different regions. So where you see the tan here, the beach is shrinking. And where you see the blue, the beach is actually growing. So you can have both in very small regions. This is New Madrid. Well, not that. That's farmland outside New Madrid. This is the Mississippi River flowing through New Madrid. And this bend right here, let's zoom back out. Sorry. This is the bend. The river meanders like that. That bend in the river is absolutely crazy. Why am I showing you this? We're maybe more familiar with sandbars than, Canyonlands out in Utah. This is deposition. When the river is up high and flooding in the spring, it will deposit and build up sandbars. And then different times of the years, the river's moving, it can erode those sandbars. And then when the spring floods come again, it can deposit on those sandbars. They are constantly moving and constantly changing all up and down the river. Okay? Okay. This is other types of deposition. This happens to also be at Cape Cod, Massachusetts here. Here you get ripples. This looks really muddy and looks really soft, sandy, like you get ripple effects near a beach edge or a stream bed. But we're talking about rocks, not sand. If this stays like this, if geology moves and that water goes away, this can turn into sedimentary rock. We haven't even finished our process how to turn these into rocks yet. Okay? We've got a couple more steps, but this can be a rock-like feature. Not rock-like, it can be a rock. And it can keep these ripples from a long time when it used to be underwater like this. This is mud cracks. These are mud cracks. I couldn't find a different picture that was bigger right away. You get an area, floods, and it's clay-like. It's the very small particles, the silty, and then it dries kind of quickly. You can get mud cracks. Okay, well, the next time it rains, those go away. But what if it didn't really rain again? What if you were out in the desert and there was a flash flood and everything got wet and then it dried real fast the next day and it cracked and then it stayed dry for a very, very long time? You can turn this can be transformed into rock. Okay? All right. Let's come back over here. Let's go back to the Canyonlands. Cool spires, all sorts of stuff. You see, look, I want you to look across here real quick. See, there's a white layer and a pink layer and a white layer and a pink layer, and you could go all the way across. It doesn't matter which tower I'm on. There is a little bitty white stripe right there running through that. And then up here, this layer right here is a nice straight line across there where it goes from white rock to dark rock. Those are layers in geology time. You are digging back into the past. You have to, you look and we think this is up high. And it is up high today. That used to be down low. And it was an area where the lake, the river, the stream would deposit stuff. It would make a sandbar. And then it would deposit more and deposit more. And it builds up in time. It doesn't build up to here. The ocean was never up here. I promise. The ocean, the sea, the lake, whatever you want to, whatever it was in this specific region was never up there. But what happens is uplift. So we have deposition. Okay? All of the material there was brought in from somewhere else and dropped and deposited. All right? It accumulates. Then there is uplift. 5,000 feet above sea level. So in other words, plate tectonics move and lift these up. And now that they're up, they stay up. And then you can actually get the whole thing to start over again because now a new stream is beginning to weather and erode as it meanders through there, and it's cutting down deeper. So there's a difference between the level it was, the level it is, and where the river is now. Because the river's cutting deeper, that's why you get the canyon. It's not flat all the way across. Lots of stuff's going on there. All right, so you still got erosion and things going on today. Okay. We still have two more things to do because we've weathered, we've eroded, we've deposited. How do you turn the stuff, the little bitty stuff, back into a rock? Well, it was a rock to start with. When you break that rock down, it becomes a sediment. It's still rock stuff. But we call it a sediment. Sediment is transported. Sediment is deposited. And then what happens? Compaction. More sediments put on top, more sediments put on top, more sediments put on top. And the weight of that squishes all this together. And when you squish this one, eventually you can squish it, and the weight of all of this will not just squish that, but it'll squish the water out of that rock, out of that sediment. And you will compact it. All right? But not you can compact things, you can also cement them. Okay? You can cement them in place chemically. So the sediments are changed into sedimentary rock. All right? So when the dissolved minerals are deposited, they can harden up. That's cementation. All right? Because those dissolved chemicals get into tiny spaces among the other sediments and chemical reaction, and it hardens up and it reforms rock. Okay. We got to look at some sedimentary rocks. I closed some of those. Those first ones were sandstone. We need to pause for a second. Hold on. We're going to pause for a second. We're back. Here we go. So, sorry, I had to pause because couldn't have enough tabs up to keep all this organized. So here we go. We still have to make the rock. We still have to reform the rock. So there are two big types of rock, clastic and chemical. Those are the two big categorizations of sedimentary rocks, okay? So the clastic side, made from weathered bits of rocks and minerals, all right? Lots of different minerals. The most common is clay, quartz. That's what's going on, okay? Why? Because clay minerals are the most common thing from chemical weathering. Why is quartz common? Because the exact opposite, because quartz isn't affected by chemical weathering. Okay? We classify these clastic rocks based on grain size, coarse to fine or very fine. Okay? So you might nickname something gravel, sand, mud, but the rock name conglomerate, breccia, sandstone, siltstone, shale. What are we talking about here? Conglomerate. This is the sedimentary rock. It's the clastic kind, and then it's conglomerate because it's got huge chunks in there. Conglomerate is just a mix of a bunch of stuff. All right, so all these different big weathered bits were then eroded and then deposited, and they reformed this conglomerate. So large size, large size. Okay, we're going to move down that chart here. We're going to move from conglomerate. We're going to move to sandstone. These are just examples of sandstone. See how the pattern in here is smaller. So the bits of rock that were weathered are smaller in the sandstone. Sandstone is often famous because you'll see layers in it. Easily see layers in the sandstone. Okay? Now, if you want to go even finer than sandstone, so if sandstone that the size of the sediment was between a 1/16 and 2 millimeters, shale is less than a 256th of a millimeter. Shale is really tiny. Shale is it's flaky. This is shale. So this is something you might actually see in Missouri right here. This kind of structure right here. In fact, in the creek in my backyard, there I can walk up and down that creek, and the rock on the side is very much like this, and it just flakes off when you touch it. Turns into little bitty, thin flakes that you can then take that rock and break it between your fingers because this is so thin. So that's what shale is. It is a sedimentary rock when all those other rocks deposited and then they were recompacted. And then when I say it's in the creek is weathered away, and this is what's sticking out on the side still. All right? Now, that takes care of this side. That's the clastic side. Okay? So the clastic are just made of weathered bits of rocks and minerals. The chemical side can also include biochemical. It's dissolved minerals that separate back out, okay, from their water solutions. So when the water evaporates, you've got all these minerals that are dissolved. When the water evaporates or boils off, those minerals are left. And so this is what we've got. So let's get rid of the shale, and let's go with coquina here. What's interesting is this is very, very rough texture. Also here, very coarse texture down to very fine texture. But we also divide these chemically by what they're made of. Calcite, quartz, gypsum, halite, and other stuff. Okay? All of these limestones right here, okay, 90% of limestones are really made from biochemical sediments. What? Biochemical sediments. Honestly, the quickest way to say this is when everything dies, it is all the plant, animal, it ends up kind of at the bottom of the ocean some way, right? So, or even just think of sea creatures. Keep it simple. Take all the sea creatures and they die and they float to the bottom of the ocean. Layer upon layer upon layer of dead ocean skeletons down there, building up, compressing the layers below them, compacting them, and turning them back into chemical sedimentary rocks. So if you have very, very coarse, right, what you can get is visible shells in this coquina here. Like, it's so rough that rock actually has full shells that are chunked in there that you can see. Made of exactly the same stuff, but with tiny, tiny ground up super fine bits, chalk. All right, so this says Sussex here, but the White Cliffs of Dover, right? This is just chalk. The same stuff you write on the blackboard with. I know you guys are used to whiteboards, but it's the exact same shells. They just got ground down before they got turned into the sedimentary rock. Lots of sedimentary rocks, chalk, shale, sandstone. They are soft rock. They're not that hard because the way they're compressed back together is not as strong as some of the other igneous and metamorphic rocks. I'm not saying all sedimentary rocks are soft, but many of them are. Okay. The other thing, something interesting, sedimentary rocks provide more clues about where and when they were formed because you can find fossils in these rocks. Now, these are full shells, but you can find fossils embedded in any of these rocks, okay? So as we look at this different chart, whether we talk about rock salt or coal or all the different types of limestone, siltstone, shale, sandstone, there's lots of fossils in all of this. And if I know the fossil, I can date the fossil, and I know, well, that's a plant. So it didn't grow out here in that type of plant didn't grow out here in the desert, on and on. I can use all of those. All right. So to finish up, let's get rid of that. Just for a laugh again, what's in the game? Sandstone is in the game. That is a sedimentary rock. Okay. Coal is in the Minecraft game. That is also a sedimentary rock. It's a chemical sedimentary rock. Flint is in the game. It is also a chemical sedimentary rock. All right. So here we go. We've got your coal, your flint, and your limestone, and all of this. Or, I'm sorry, sandstone is over here. I didn't mean to say limestone. You got all these sedimentary rocks. They come from, here we go, one more time. Weathering breaks the rock. Erosion moves the rock. Deposition drops the rock. Compaction and cementation make new rock from the old rock bits. That's sedimentary rocks. Have a great day, guys. We will get metamorphic next time. Then we'll be ready. We'll get close, wrap up, and have a test.